Class will help some of the basic of the electrical studies. So let's start up with electricity. Electricity is a driving force that provides power to the houses, businesses, and industries. As I underline these things, industries will be machining, like machining, making parts there, that requires electricity. Either if it's anything electrical, hydraulic valves. If it's hydraulic valve, it should still need a electrical component to drive the hydraulic. Light at houses or in the industries. So these are all run by electricity. When we talk about electricity, we don't want to forget the sources. We have two different sources: electrical, alternating source, and direct current source. So we have it alternating, we can call it AC, and direct current we call DC. So we will dig into these things deep little. Now the AC current, a current that it can reverse its direction. A current that can be reversed, it's called AC current, right? AC current will flow in both direction. AC current will go in both directions, and we also call it bidirectional. So it's going in two direction. It's going like that. It's sinusoidal wave. We will talk, this is too early to talk about these things, but we will come back to these things. Well, where DC current is that cannot reverse itself, and DC current is a current that cannot be reversed. It cannot reverse its direction. It is also called a unidirectional current. That means only one direction. So we will dig into these things later on. So what will happen if we have a DC powered battery? If we charge it with an AC power, the same voltage rating, what happens? We will discuss this thing in the very last thing. So don't forget, before we discuss about electricity, it's not bad to talk about atoms, because electricity will be something, a big picture. Let's talk about atoms right here. Atom is a basic building block of the universe. Basic building blocks are called the atoms. So everything, our matter is made of atoms. Everything is made of what? Atoms. So what is matter actually? Matter is anything that occupies space and has a mass. Mass, we say like kilogram or anything, or pound. So matter is everything that occupies space and has matter is everything that occupies space and has a mass. We call that matter. Now what atom is actually? Atom is the smallest part of an element. Element will be like a chemistry element, if we must talk about that. So we are going to the smallest part of that thing, so just to see where that electricity come from. Now we know that we will know this atom has three components, or three parts of it: electrons, neutrons, and protons. Electrons has a negative, we can say, charge by right now, but we will discover it later. So what these things means: neutron has a no charge, it's neutral. Proton has a plus charge. So these are all in atoms. Now when we talk about element has three parts: nucleus, shells, and this is our nucleus here. I hope I spell it right, nucleus. And these are our orbits, or we call it shells. So nuclear consists of proton and neutron. So proton and neutrons are in this portion. The number of proton is referred to as atomic number. The number of proton is referred to as atomic number. Simple is that. We're leaning toward chemistry here, but it is important to have these things. I wrote this example. Oxygen has atomic number of 8. That means it's located in number 8 in the periodic table, or it has 8 protons in here. So this is easy way to remember. Atomic number is also represented by the proton, which is in the nucleus. Now electrons orbits around the outside of the nucleus. So the electrons will be right here. If this is oxygen, there is a nucleus and the proton will be here. So oxygen atomic number is 8. So that means it has 8 proton. The law of charges. So what does that mean? The law of charges. Opposite charges attract and like charges repel each other. If I have plus here, it's a magnet plus side of it, and a magnet here. If I go this way, these will repel each other because these are like charges. It will push each other back. But if I have a negatively charged magnet here and positively charged here, they will attract each other. This will go to this direction. They will be attached to each other. So this is called the law of charges. Opposite charges attract and like charges repel each other. Now we talked about oxygen and their atoms and oxygen atom and their orbits and proton number. Now let's see what electron orbits are. Electron orbits are atoms have a set number of electrons that can be in one orbit or shell. A set number of electrons that can be in one orbit or shell. We call it shell or orbit. It is called electron orbit. So we can find, this is the formula that we will find how to calculate the electron number in each shell, where n is the number of shell, number of orbit. Which number will be that? Like the numerical or shell. So for example, oxygen has 8 protons, right? 8 protons, oxygen. It's a molecule, that's why we write it down as 2. 8 proton, we know that because we just said it, because atomic number is 8, so the proton is 8. Now let's see how many electron does it have. Now let's not forget that every shell should not exceed more than 8 electrons. So let's go to the shell 1. Is 2 times 1 to the power 2 is 2. So oxygen here, so that's my nucleus. It's my shell 1 or orbit 1, has 2 electrons. Now n, this is n equal to 1, this is n equal to 2. So it'll be 2 times 2 to the power 2 is equal to, it'll be 4 times, be 2 to the 2 is 4, right? And that's 8. And shell and orbit 2, we will have 8 electrons. But here we only have 8 protons, so that means we have 6 electrons left. So they will be matching in a neutral place, in a non-reactive place. The electron and proton should be equal. So 2 here and 6 right there. So we have 8 electrons. So, and we said, like, it's since we have 2 less electrons, it'll be borrowing, or it'll be in any chemical reaction, it'll be taking 2 electrons from any other element. So this will take 2 electrons, the charge will become -2 or 2 negative. For example, water, H2O. If you break it down, it will be H2O2. And this is non-reactive because this is a compound right here, and these are just the elements. This is element, this is a compound. These are the element, this is the compound. So the elements get together and make a compound. Water is a compound. So I hope this makes sense. And now let's move on. Valence electron. I kind of talked about here. The outer shell of an atom is known as a valence shell or valence electron. The outermost, in this case in oxygen, this is outermost shell right here. This guy is outermost shell of atom is called valence shell or valence orbit. The electron in valence shell or valence orbit is called valence electron. So we also say, like, valence shell cannot hold more than 8 electrons. The valence cannot hold more than 8 electrons. I think I said somewhere that the orbit cannot hold in more than 8. That must be not right. That's not right. My apologies for that if I said that, because valence electron cannot be exceeded more than 8 electrons, or valence shell cannot hold more than 8 electrons. For example, let's talk about oxygen. Let's talk about nitrogen here. Nitrogen has a nitrogen is just before oxygen, which will be atomic number is 7. Let's change this color. So that means proton numbers are 7. To find the electron number, we will have to apply that formula to n to the 2. The first one, n, when n is 1, will have only 2 electrons. When n is 2, that will be 8. But 8 and 2 will become 10, but we only need 7. So the second one will have 5. So that will be your valence shell. So let's draw this one here, nucleus. And this is the first shell right here. So it has 2 electrons. The second one, 8 minus, what do you have? I'm sorry. If you have a, that's not, so we have a 5 there because 2 and 5 are 7. 2, 3, 4, 5. So 5. Outermost shell or outermost orbit has 5 electrons there. So this is a valence shell right there. As we said, it cannot go exceed more than 8 electrons, so we are okay there. And thus that means it requires 3 more electrons to be 8 and to become satisfied. So that means the electron or this charge will be 3 negative. So it has to give 3 electrons from an element to become saturated. This is a reaction type because when it combines that with any other element, the other element will share or give the electron to this one so they can bond together. Conductors. We talk about conductors. We talk about electricity. Yes, we will not forget conductors. Those materials that permits electron to flow through them. The material that permits electron to flow through them, like copper, gold, for example, it's a good conductor. Most conductor contains fewer electron. You can say fewer electrons in valence shell. So for instance, I said a copper. Copper has atomic number of 29. So the valence shell should have 1 electron. And just to prove this thing, so I said, like, we went by that formula that we have in the first orbit. The first orbit has a 2 electrons, so we thinking it has only 3 orbits: nucleus, 1 orbit, 2 orbit, 3 orbit. Let's make it beautiful right here. So the first one we say has 2 electrons. The first one is right here. First one has 2 electrons. The second one has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now the third one has 18 electron. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And now there is a fourth one too. No, not a good draw. Okay, so only have 1 electron, because 2 and 8, 10, 10 and 18 is 28, and 1 is 29. So we said its atomic number was 29, so we got 29 electrons here. But this is 1 electron. It has an outermost shell. It has 1 electron. It's subject to be lose, or it be losing this electron. Well, in that case, it will have a give it to somebody, or not somebody, give it to another element. It will become positively charged, or so that will end up with a 28 electron. It will balance out the equation when it try to. We can't forget insulator too. When we talk about electricity, the insulator or the material that will not allow electrons to go through it, or our atom that contains 7 valence electrons and 8 valence electrons. It does not give up its electrons easily, because giving up 7 electrons and 8 electrons are extremely hard to do it, compared to the 1 electron or 2 or 3. So insulator, that's the reason why it's not conductors, because it has more valence electrons in the outermost shell or the valence orbits. The example of the insulator will be rubbers, plastic, glass, and etc. Anything that has that is not conductors and they have more valence electrons, these are insulators. Now we will talk about the semiconductors. Anything between the insulators and conductors are called semiconductors. So that being said, any atom or any element that has 4 valence electron in their outermost shell, they are called semiconductors. For example, silicon. Silicon is a semiconductor, so that means you can use it either as a conductor or insulator in some cases. So it has 14 electrons, 14 proton, or the protein atomic number is 14. So it has 14 protons there. If you do the math, so in the first shell we have an electron shell, we have 2 electrons. The second one we will have 8 always. If you go by this formula, 2 times n to the 2. So the first one will be 2 electrons. The second one will be 8 electrons. So it will be 10 right now. The third one will be 2 times 2 and 8 is 10, and we have 4 more. There will be 4 electrons there. So 4 electrons are left. So it needs 4 electrons to have it complete the shell, the third shell or third orbit, or it has to give up to have this one complete. So it should have plus 4 charge or negative 4 charge. It depends on what condition it gets in and what it's acting up with. So as I said, it has to get 4 electron, or it has to give up on 4 electron. So because it's not easy to do under normal conditions, so it would require a big catalyst there. Now talking about the molecules here. The last thing will be molecule. Smallest parts of a compound. As we talked about earlier, water is a compound. It's made of oxygen and hydrogen atoms, or the elements of hydrogen and oxygen. So this is the compound, become a compound right here. So chemical reaction is a simple reaction. We call it addition in math. Its smallest particle of water that can exist is a molecule. The smallest particle of a water that can be existing is called molecule. So if you break water in the smallest part, if that is exist, it will be a water molecule. Molecule. But if you break the water, there is some catalyst that breaks it, some heat it up, for example. It will give you oxygen gas and hydrogen gas. So these are not molecule no more, these are atoms. And atom is the smallest part of an element or anything. One atom. Please don't forget that we'll be talking about electrical components in next videos. So please stay tuned and be careful. Please subscribe this channel for more knowledgeable videos. Have a good day.